Good afternoon, all participants and presenters. Today we are coming to fifth day or last day of our event. Today there will be two technical sessions. Then we'll have the concluding session. So first, I would like to invite Mr. Lokesh BM to speak on ABB motor efficiency improvement, application matching with motor technologies and different case studies. Let me give his brief introduction. Mr. Lokesh BM is Vice President of R&D Hub and Engineering Manager in ABB India Limited, Bangalore branch. He has completed BE in Electrical and Electronics Engineering from Mangalore University. He has overall 23 years of experience in design and development of three-phase induction motor. He started his career in Kirloskar Electric Company as a management trainee and served in design and engineering of three-phase induction motor for 6 years. He joined ABB Bangalore in 2005 for a new low voltage motor plant project and now is on date heading R&D and engineering team for IEC low voltage motor, India based in Bangalore. So with this, I would like to invite Mr. BM Lokesh sir. You may go with your presentation.
Okay. Can you hear me?
Yeah, perfect.
Okay. Thanks for the introduction, and good afternoon all. I would like to thank everyone for this opportunity to present this topic today. So let's begin. So my topic would be on, as explained earlier, on the VFD applications, on some motor technologies. We also cover on efficiency topics, which is very important now.
Sir,
and
look, excuse me. Yes. Your screen is not visible. Your screen.
Okay.
You may share your slide, please.
Can you give me that option for sharing?
You are given.
I can't see anything.
You are given the axis.
Okay. Okay.
Yeah.
Now can you see?
Yeah. Perfect.
Okay. Thanks. Okay, let's get into the topics. What I wanted to share. I'm able to move the slide. Not able to move the slide.
Just click on the presenter, not on the software. Just click on your PPT file, PowerPoint file, and then you will be able to move it.
Okay.
Yeah.
Now it's moved, I think.
Yes, we can see your software.
Okay. Thanks. So as I said, the main contents would be on the motor performance characteristics. So this is the basic concept. We see on the TS curve, we see the starting performance of the motor. So with this, we go with the why VFD duty motor or why VFD is required for motor. Then there are certain points where on the checklist we need to go while selecting a motor for VFD applications. Then the type of loads, which is very important. We need to know what type of load for which is the application the motors are being given. So we try to see different types of loads and have a look on that. Then of course on the loadability curves with respect to VFD duty motor. Then we go on what exactly is the savings with respect to VSD. While we see all this, there are some challenges or some precautions we need to take while using our motors for VFD, right? So this is also important. So we would like to cover on that also. And what exactly we need to pay a special attention while selecting motors for VFD applications. Then finally, the learning from all these slides, whatever we see now. And then I would like to touch upon energy efficiency topics. And finally, the case studies. So I have collected some case studies where our motors have gone and installed at customer sites. and what exactly is the benefit customer is going to have. So to start with, I said we start with basics. So this is very well known to everyone who is using a motor, and is a basic concept. So this is a typical torque speed curve of an induction motor. So if you see, there are some important parameters from A to E which is mentioned. So we use every day in and out. If you see any data sheet or a torque speed curve, you will find these details, right? So A is nothing but the what we call it as lock rotor torque when we plot with respect to speed and torque. So A is nothing but the lock rotor torque, or commonly known as starting torque of the induction motor. So B is the pull-up torque. C is the breakdown torque, or what we call it as POT or pull-out torque. So other words, we also can call as the maximum torque that the motor can develop. So this is on a DOL curve. So what exactly will happen with a VFD? So definitely this can be pushed much earlier at the different speeds or lower speeds also. So whatever is the maximum torque, that can move up to 10% RPM or maybe 20% RPM. So throughout the speed range, you can get the maximum output here or maximum torque levels. So D is nothing but the full load torque, and synchronous speed is what is mentioned as E. So this is the typical torque speed characteristics of the induction motor. Now going to the next topic, when it comes to selection criteria of an induction motor for VFD applications. So what exactly we need to take care? So why VFD? So this question comes to everybody's mind. So if you want to change the motor speed in a DOL application, would it be possible? So definitely it is not possible. So when you want to change the speed different from the rated RPM, so definitely you need to have some options. So one best option would be using a VFD. So what are the main reasons to see that we get more energy savings with respect to VSD, and also there are some other benefits also. So we would like to see that. So we get a very soft start while using VFD, definitely, right? So it starts from 0 RPM to the rated RPM. It will be a very smooth start. So when compared to DOL, what exactly happens? The DOL motors, you give a full voltage and full current at a time. The moment you switch on the motor, it will start taking the full current, right? So the starting current will be very high. So accordingly, you need to select all the equipments also. So in VFD, it will be a soft start because you are lowering the RPM starting and then reaching the maximum RPM. So what exactly is the benefit? So you get a longer service lifetime with respect to mechanical components because it is a very smooth start. You are not giving any jerks on the motor. Then on the finished product, so definitely the most precision you are controlling the speed and other things. So definitely it will be on the process side, the best quality of the product you are going to get. So overall, if you see, it also increases the efficiency of the system point of view also. So going to the next. So this is the basic principle. So whenever you are dimensioning or selecting a motor and drive, so you need to consider some important parameters listed here. Like one is on the network, the converter aspects, what exactly VFD unit to select. From the motor point of view, what you should see, and also from the load perspective. So these four things have to be considered for a VFD duty motor, right? So on the network side, you need to know what exactly is the voltage which is coming onto the motor from the input side, from the transformer side. So you need to know what voltage, like 380, 415 or 690 volts. So depending on that, the insulation systems will also change with respect to motor, right? For a 415 volt system, there is a separate insulation, and for a 690 volts, there is a separate insulation. So I will come to that topic in the next coming slides. Similarly, from the converter point of view also, and the motor point of view also, you should know the thermal loadability of the motor, right? And also the speed range. You should know what is the minimum speed, maximum speed, so that which is also important, and the maximum torque required. So definitely you should know what is the maximum torque it can deliver. And from the converter point of view, you need to know what is exactly the load type, whether it is a contracted curve, whether it is a constant torque, constant power. So these things are very important while selecting the or dimensioning the motor for VFD. So all these things are the four parameters you need to consider in mind. So talking about suitability for VFD. So when I say there are some checkpoints you need to see, in the previous slide also we have seen. So in continuation of that, you should always see on the load capacity, what exactly is the load and all those things. And winding insulation level, as I said, If you have seen, dV by dt is nothing but rate of change of voltage with respect to time. If you see on the right hand side, there is a curve which is mentioning the rise time and also the voltage peaks. So if you see, when using an VFD, definitely the voltage peaks which is coming onto the motor or the winding, which is harmful. So you need to know what exactly is the voltage which is coming onto the motor terminals so that you can take precautionary measures. So there is a new IEC standard just come into picture where it mentions IV IC class category, and it has mentioned the starting levels and the severity levels with respect to A, B, C and D categories. So D being the extreme. So we give the insulation class which is able to meet the C category level. So we should know what exactly is the site condition, what is the voltage levels at site. So all these parameters like the peak voltages, the dV by dt, rise time, bearing currents, or if there is any overheating due to harmonics, all these things have to be studied before offering the motor for VFD application. And also, as I said, you should know the maximum torque. Bearing construction and lubrication, definitely this is also an important factor because for VFD application there will be a circulating currents if we go on higher ratings like from 100 kilowatt and above. So there may be chances like bearing might fail. So we need to consider what exactly the bearing selection should be for higher kilowatts. And fan, the noise and the mechanical suitability, this is also important because on the speed range, if the speeds are little bit less, but lesser than 30%, maybe you need to go for a force cooling motor because at lower speeds, the motor cooling will be not sufficient. And the fourth point, you also need to have the critical speeds of the motor. So critical speed is also important, and cooling I have covered, and of course the critical speed and cooling. So now we have seen what are the checkpoints with respect to VFD, and now we will go to the load types. As I said in the beginning, there are different load types which we need to consider. From the application point of view, first one is the quadratic torque. So this is simple when we call it as for a pump or a fan. So this we call it as a quadratic torque, where the power and the torque characteristics is a parabolic curve here. Now when it comes to constant torque, you can see here, that means you will have a constant torque throughout the speed range and power varies with respect to speed. So the best examples are conveyors, feeders, screw compressors, etc. So when it comes to constant power, the power remains constant throughout the speed range. Torque is going to vary with respect to speed. So the best example would be rollers. So one typical application, what we call, you have a constant torque and also a constant power. So this is a very typical example here. The best example would be on the paper machine roll or bridle application. So what does it mean? You have a constant torque up to the base RPM. Then after 50, for example, you take it as a 50 hertz. After 50 hertz, the torque is going to vary with respect to speed, but power remains constant after the field weakening point. So we call this as a field weakening point if it is a 50 hertz region. So let's go in detail and see what exactly is the application and how does it look. So if you see the picture here, the fan application, so this is the best example you can see in the picture here, and the curves also corresponding curves. So the centrifugal pumps, fans, mixers fall under quadratic torque applications, right? So the maximum speed in this application, the maximum speed is set to near to the base speed, and when it comes to cooling, self ventilation is sufficient, so you don't have to go for a force cooling ventilation here. So coming to the constant torque, again, you can see the picture here. The best example would be conveyors, roller tables, or maybe cranes, feeders, compressors, extruders, or cement application. So here, the minimum and maximum speed points are set as high as possible in the motor loadability curve. So this is an important factor here for this type of application. So the mechanical gears, if there are any gearboxes, so that ratio has to be considered here during the selection. And check on the overloadability. So if there are any overloads considered here, so those things have to be taken care. Next application, what we saw is on the constant power application. So best example would be winders, coilers, or rollers, maybe in steel application, right? So the speed range is set to the field weakening area. So this is the best example, like winders, coilers. So here self ventilation is sufficient. The one more important factor, as I said, so overloadability should also be considered during the selection. So one critical application, as I said, maybe the rolling mill or bridle application motor, where you have a constant torque up to 50 Hertz, then the constant power. The power remains constant up to 50 Hertz. So this is the best example for constant torque and constant power applications. So now after seeing the different loads, we jump to the VFD energy savings. So how exactly we get the benefit while using VFD? So if you see the curve on the right hand side here, we see a flow, torque and power versus speed. So this curve is plotted with respect to speed, and when it comes to relation of flow, it is directly proportional to the RPM. Torque, when it comes, it's proportional to the square of the RPM, right? And when it comes to power, it varies with respect to cube ratio. So if you see a traditionally pumping station or a pumping system, so definitely it is controlled by a mechanical system like throttling and other systems, right? So what exactly happens? You will not have a control on the flow. So therefore, there is no energy saving with respect to traditional pump. But when it comes to a VFD, when you are using a VFD, you can much or precisely control the flow by varying the speed. So a converter drives a pumping system according to the requirements, and therefore there is no additional pressure or loss in the pump or valve. So this is the benefit you are going to get. So the savings from this, definitely from 30% to 70%, it can vary with respect to throttling application. So I would like to take one example here to just to show you which of the methods when you are controlling with respect to pumping system or with respect to pump application. So this example, let's see. So if you see from the affinity loss, the pump or a fan, how does it vary? We have seen in the previous slide. The flow is proportional to speed, pressure is proportional to square of the speed, and power will vary with respect to cube ratio, right? So when we take a typical example here, where this means a pump running at 80% of its nominal speed will produce 80% of its nominal flow, right? If you see here, 80% of the flow here, and when it comes to power consumption, it is only 50%. The dotted line you can see it is only 50% energy needed. Now you can understand what is the requirement here. Now, but in reality, if you see, most of the pumps at site are oversized or maybe over-designed due to considering the extreme conditions. But if you are not using a VFD, when you are using a DOL, when you switch on the motor, the pump will operate at the full speed. So you will not have any control with respect to the normal flow. So let's see the different methods which are used on the traditional aspects. So one is on the throttling, where you control the valve by closing valve and opening the valve, right? So this is one traditional method. The second traditional method, what we see is on the bypassing. So this is also most popular. And the third is on and off control. So if you see, these three are some of the traditional methods which the pumping system has been used. So now let's continue with that example and see how these traditional methods, when it comes to energy efficiency, how exactly it behaves. So we take one example comparing the non-needed flow for an example. For this case, at least we are considering 70% of the installed nominal capacity. So with respect to 70% of the installed nominal capacity, what exactly is the power consumed? So let's see. So from the throttling example, what we see, you can see the calculation here with respect to flow. So the power consumption is 89%. So whether it is energy efficient? Definitely not. So let's go to the next example. By bypassing mode, if you see with similar calculation, the power consumption is 82%. So definitely this is also not energy efficient. When it comes to on-off control, when you do the calculation of the power saving, here it's only 70% of the energy is used. So definitely this is also not energy efficient. The same application, when you prefer a VFD or when you use in VFD, you can see the curves here. The power consumption is 45%. So you can compare all the three traditional applications where it was controlled, and now with respect to VFD, you have a better saving here. So definitely this method we preferred for energy saving. So similar pumping station, we saw an example with respect to one single pump, but when we talk about the system efficiency point of view, for example, we are taking here a pumping system where you have two systems. One is a conventional method pumping system and an energy efficient pumping system. The bottom one is a energy efficient pumping system where you see a huge difference, where the system efficiency of a conventional system is 28% while compared to the energy efficient pumping system of 82%. So what exactly this makes a difference? If you see the motor here, The standard motor is used of an efficiency of 91%, but when it comes to a energy efficient pumping system, you are using an energy efficient motor with efficiency of 96%. So this is a huge gap and which is contributing on the energy saving. What happens with respect to this? Definitely, when the input power calculation you do, the input power consumed for this particular application is 122 kilowatt. When it comes to this, it is 359 kilowatt. You can see a huge difference here. That is why the efficiency of the pumping system has been increased. Moving on to the next slide, as I said in the beginning, so while selecting for a PFD, there are certain conditions or certain criteria we need to meet or we need to consider definitely. So these challenges or problems to prevent by using VFD motors, one such topic would be on the winding insulation. So this is a huge topic, but I'm not going in very much detail here. So definitely on the insulation grounds, as I said, for different voltage levels, the insulation category is going to change because higher the voltage stress is going to be higher on the winding. So definitely you need to take care with respect to the winding system. So winding being heart of the motor, so definitely you need to give a lot of precautions with respect to VFD applications. So if you talk about the 500 volt system, so lesser than or UN is nothing but the rated voltage. If it is less than equal to 500 volts, then we prefer a standard insulation. If it is less than equal to 600 volts, you need to have a standard insulation plus a du by dt filter, or you can go with a special insulation. If you are not going with this first option, you can go with a special insulation here. So what happens if it is less than or equal to 690 volts? For 690 volts, definitely you need to consider special insulation and also du by dt filters at the converter output. So you might have experienced here for any 690 volts drive, the du by dt filters are by default. And for example, 600 volts or less than equal to 690 volts of a cable length we take greater than 150 meters. So definitely you need to have a special insulation here. So talking about bearings, so when exactly you need an insulated bearing? So for VFD application, definitely you need to have in mind there will be a circulating current. Every motor will have a circulating current, of course, but when it comes to bigger ratings, as the rating goes higher and higher, the circulating currents will also be on the higher side, which will definitely harm the bearing. Since it is a circulating current, it will be a closed loop, so definitely bearing damages can happen. So how exactly we prevent here? For the ratings lesser than 100 kilowatt, so we don't have to give an insulated bearing because it is not so harmful. So this is based on the studies what we have made, then we have given this action here. So similarly, if it is greater than 100 kilowatt, or if it is falling under 315 frame, or if it is falling under 355 frame, so definitely you need to give a insulated bearing and at the non-drive end. So why we prefer non-drive end? Because the starting point is from the shaft and it will be circulating with the ND side bearing. So if you are providing insulation for the non-drive end, your circulating currents is going to break here. So to break the loop, we are giving at the non-drive end. So there are some other options, maybe other manufacturers give. They provide insulated end sheets also. That is also an option. So whatever we do, we need to break the circulating currents. That is the intention. So any rating which falls greater than 100 kilowatt, or if it is in 315 frame, it will go with the insulated bearing, the non-drive. And for 400 frames and greater than or equal to 500 frames, we need to give an insulated bearing and also a common mode filter. So common mode filter is also, we'll talk about in the slides. This will also reduce the bearing currents. So we saw on the insulation part and the bearing selection. Now we talk about the entire system. So what is EMC? We call it as electromagnetic compatibility. This is nothing but when we use the high frequency components in the VFD, so this might cause a electromagnetic interference. So definitely there are other equipments which are connected at site. There may be plenty of equipments where the motors and drives are there. So they should not harm the other equipments because of this interface. So how exactly we do that? You see the picture here, there are certain things we need to take care for this. On the cable part, we provide a proper shielding to the motor terminal box, and there are possibilities where we can provide EMC glands which are available, and also EMC cable boxes. So by providing this problem of electromagnetic interference can be avoided. So another such aspect with respect to common mode filters and DU/DT filters. We will see what exactly is the difference. So what are common mode filters? Common mode filters are nothing but they are installed at the output of the frequency converter. You can see the picture here on the right hand side. These are in circular cores which are in red color. These are the common mode filters. So these are provided at the output of the frequency converter. So why do we give this? So these common mode filters definitely will reduce the risk of bearing currents. So that is the reason we talked about the bearing currents there. So by providing this, you are reducing the bearing currents. So another aspect, what we spoke about DU/DT filter or a series reactor. So where exactly we give this reduces the peak voltages. We spoke about peak voltages in the previous slides. So by giving a DU/DT filters or a sine filters, the voltage peaks which is coming onto the motor windings will be reduced. So what exactly we learned from the previous slides, I will just put on the bullet points here. You can read here. So the first point would be on the selection of the motor, like select motor according to the correct load type, right? So you need to know the load, what exactly is the load, and how exactly or what exactly you need to give from the motor or from the drive perspective. This is an important point. So use the correct minimum speed for the constant torque drive. So you need to have the minimum speed and maximum speed. This is also very important with respect to applications. So sometimes you give force ventilation. So it can be more optimized than self ventilation, right? So force ventilation, when do we give? When we have a speed range which is lesser, maybe lesser than 30% of the speed, there we recommend force cooling. So if you are opting for force cooling, you can give it in the same frame because that is being taken care. And if you are opting for a not to give a force cooling, then we can still give that, but frame has to be derated. That is why I'm saying it can be more optimized sometimes with respect to the self ventilation. So the fourth point is on the limiting temperature rise with respect to class B. If you see on the insulation perspective, most of the insulations what we give is class F, and when it comes to temperature rise, it is limited to class B. So why do we limit with respect to class B? Definitely, the temperature rise is one of the important factors. And as a thumb rule, you know, every 10-degree rise in temperature will reduce the winding life by 50%. So even though you are using class F temperature insulation, you are limiting to class B, so that your motor life increases. But there are options where, with respect to different conditions or maybe on the customer requirement, you can still use class F limits also. So the fifth point would be on defining the overload and speed range correctly. So this is also important if you are not considering overload and if you are selecting the drive on the nominal current, so definitely you will have end up with problems inside. So the sixth point on the inverter dimension should always be on the duty cycle. Yes. So duty cycle is very important. You should know how exactly the cycle is and also the motor current with respect to drive. So remember the voltage drips. So if there are any voltage drips, so definitely it is directly proportional to the torque. So there will be an impact on the torque also. So this point should also be taken care. The last but not the least, so you should also have a check on the cable. What is the type of cable, whether it is a shielded cable or what is that you are using, and also the cable length. So this is an important factor. Most of us, we don't ask during the inquiry stage. Only at the site when there are failures, we go and do the analysis there. So if you know the information much before on the selection of the motor, so it is very good. Finally, concluding on this, whatever you saw on the previous topics. So there are 5 questions you need to ask. What is the application, which is very important? What type of load, and the speed range and the overload cycle, right? So first 3 are very important, and type of VFD. So this also matters sometimes, and whether the motor starts with DOL or not. So sometimes we get an inquiry where we, even though it is for VFD, they want the motor should be suitable for bypass DOL. So if you're not considering the DOL option, so you can end up with problems with respect to starting current. All those aspects will come into picture. I think we are covered on the VFD part, on the application part. So now we will jump to the energy efficiency part. So before going in, this is a general slide. Most of you might have seen here. So if you see on the electricity used by the power industry, greater than 40% of the electricity is used by power industry, and when it comes to motor, two-thirds of it which is used by only electric motors. So now we can imagine why motors are very important. So there is a huge option or a huge place where you can do the energy savings with respect to giving energy efficient motors. So our job, or as a manufacturer, our option would be to save energy and optimize operations in a sustainable way. So coming to this slide, I just wanted to cover on the national and international regulations. So if you see on the globe map, there are different countries marked here. If you see, for example, India, we have a BI standard. So each country has its own national standard, and also we are following international standards. So whenever we are ordering motors or when we are exporting to other countries, so this we need to keep in mind what exactly the standards have to be met. So accordingly, motors should be given or maybe exported outside. When it comes to India, we follow BAI standard, and the standard number is IS 12615 2018 version, and all our motors are BIS marked. If you see our motors nameplate, there is an ISI mark on the nameplate. So similarly, different countries like Vietnam, China, Ecuador or Canada, so these also follow national and international regulations. So you should be aware of these standards while placing order or maybe importing or exporting motors. So this slide, if you see how the energy efficiency levels are there, you see on the 1, 2, 3, 4, 5 up to IE5. If you see previously, before IE1 or IE standards came into picture, they were called as EFF1, EFF2. Now after that, there was a change where we called efficiency as IE1, which was the minimum standard efficiency. Now no longer exists, because even in India also IE2 has been made as a minimum standard. So there is no IE1 motors here. So minimum efficiency level in India is IE2. So similarly, when it comes to Europe, like all the European Union, they have made standard as IE3. So IE3, any motors which are going exported to Europe is minimum IE3. And further to the next level, from 1st of July 2023, they are making IE4 as the minimum efficiency standard for a particular rating. We talk about 75 to 200 kilowatts. So IE4 would be the super premium efficiency. So IE5 also we have on the IE5, what we call as ultra premium efficiency. Of course, this standard or IE5 class efficiencies are not defined in some standard, but some of the manufacturers are already making that. So whenever we talk about efficiency, we always say I efficiency from IE3 to IE4, IE3 to IE5. So what exactly we do? So talking about efficiency is nothing but output by input. So there are loss factors which are considered, like I square R loss with respect to stator, rotor, and there are different losses with respect to friction, windage, tail load loss. So the moment we try to reduce the different loss factors, your efficiency is going to improve. So that is how we do. But when I talk about the positive effect on the life cycle cost, so there are 4 important parameters we need to consider: on the quality of the motor, the noise levels, and the efficiency class, and the temperature rise. If you are taking care of these 4, you will have a very positive effect on the entire life cycle cost. So how exactly we do? As I said, there are high permeability steel or the steel quality, the superior quality you go, the square or loss, iron losses are going to come down. So thereby you're reducing the magnetic losses. So similarly, you're putting more amount of copper in the windings, therefore I square or loss, so the copper loss is going to reduce. So how do you improve with respect to quality? Definitely there are improved bearing housing designs, use of quality bearings, grease. So all these things will relate to the quality of the product, right? From the noise perspective, definitely you can go for an improved airflow, improved fan designs or fan cover designs or bearing designs. So this is how you reduce the noise factor. So talking about different technologies. So definitely when I talk about technologies, you see these 3 are the running topics on the motor technologies. If I talk about the induction motor, definitely there are certain limitations above IE4. When you start designing or maybe reaching IE5 levels, it is very difficult with respect to induction motor technology. So that is why there are different new technologies which has come into picture, like SynRM, synchronous reluctance motor, or a permanent magnet motor, for the next futuristic technology, maybe ferrite assist CNRM motor. So talking about CNRM, which is having great advantage compared to all other technologies because there are no magnets in this rotor. And if you see the rotor design, because of the new rotor design, what we are showing in the picture here, because of this, there is no induced current in the rotor. So therefore, there are no rotor losses. So completely the rotor losses is zero. So you can imagine the difference in efficiency. So we will see in detail much higher. And if you see the advantages, so definitely on the efficiency point, higher power density, it has an accurate speed control, lower wearing temperatures, so easy to maintain because there are no magnets here, only the rotor profile is different. So you can straight away replace the rotor of an CNRM rotor on an induction motor. So that kind of flexibility is also available. So as a package efficiency, it is always verified with respect to testing and designed exclusively for variable speed operation. So talking about permanent magnets, so similar qualities are also there, but you have magnets inserted inside the rotor. So maybe this may be a disadvantage because when it comes to rare earth magnets, there is an uncertainty with respect to cost variation. There is a demagnetization risk, maybe more difficult from the service point of view also, right? Coming to ferrite assist, yes, definitely you have more advantages here also, but it is only available for the smaller frames, so bigger ratings are still yet to come. So talking about the innovative motor and drive packages. So when it comes to package with respect to CNRM technology, you can see here there is a standard motor you can add with a special rotor of a CNRM design. And when it comes to standard drive, you don't have to replace the drive. There is a new software which can be inserted in the module. So you can still use the same standard motor, standard drive with a special rotor and a new software. So it gives a revolutionary drive package. And in this also, we have two options where there is an high output CNRM package. So higher output means you are giving a higher output in maybe a lower frame. So what happens in this? So when it comes to overall equipment size, definitely it is going to come down. From the cost perspective, also you will get a maximum benefit here. So this high output package series is also available. And IE5 ultra premium efficiency CNRM package, if you see here, as I said, energy losses are reduced by 40% compared to IE3. And the most advantage would be these are interchangeable with IE3 induction motor. So what is the key to success with respect to CNRM technology? So if you see here on the induction motor, if you talk about IE3 induction motor here, there are different kinds of losses. So from the 100% losses, you have rotor losses, stator losses, and other losses like friction, windage, and stator. So what exactly happens on CNRM, IE5 CNRM motor? If you see here, straight away the 40% of the losses, what we call it as rotor losses, is eliminated because there is no induced current, so there is no losses in the rotor here. So you can get the 40% of reduction in losses, so definitely your efficiency is going to be increased here. Similarly, on the high output package, as I said, you have a different advantage of giving a higher output in lower frame. So similar exercise you can do here using a CNRM rotor, but you are giving at the same time you are giving a higher output also. So definitely from the process point of view or from the equipment point of view, on the cost perspective, you will have more benefits here. So overall, if you see, these are some of the benefits when I talk about induction CNRM technology and drive as a package for a customer. So definitely these are magnet-free designs. As I said, there are no magnets. So definitely it is user-friendly and service-friendly. Then packages available for quadratic torque applications like pumps and fans. So these are very competitive with respect to new technologies. From the reliability point of view also, and the lower bearing temperature, there's a lot of benefits with respect to that. So definitely these are designed for variable speed operation, and when it comes to advanced open loop control softwares are available. And definitely on the support side also, you have a global ABB support because not many models have been given and not many experience is there with respect to CNRM technology now. So I also wanted to touch upon this topic, which is going to come in future. So now a new standard has come where they say that is 60034-30-2, which the number is mentioned here. So this standard defines IE class efficiency, and also you can compare with different technologies. So if you see today, when you compare full load, full efficiency performance of different motors. So you need to have the losses at partial load. So that point is not there. So now the standard is forcing us to use this points like 1 to 7, 1 to 7, whatever is marked here. From these points, you need to measure the losses at different load points. So manufacturers are need to provide these losses. Even the customer can ask in future. From 1st of July 2022, it will be implemented for the motor side, and drives it is already implemented from 1st of July 2020. So what does it do? This enables different motors in partial load conditions with variable speed drive. So if you see here, the points 3, 2, and 1 are mostly relevant for the constant torque applications like conveyors, beds, hoist drives, etc. And at the full load, and the test points 5 and 4 are relevant for the half load condition. And if I say 7, 6, 5, 4, and 1 points, if you see, are mostly relevant for the quadratic torque applications like pumps and fans. So this definitely will be implemented in the next year. So talking about thin RM here. So why I said on the different load points on the different speed variations. So definitely this is very important. So what we are going to see here, there was an experiment conducted with respect to the induction motor package efficiency and IE5 thin RM package efficiency. So the two different technologies on the induction motor and thin RM technology was compared here. The example what you see is on the motor of 110 kilowatt 4-pole motor, and the package efficiency is 92.5%. So you can see the dark one, the dark shade, the bottom one is the load curve, the dotted one is the IE3 induction motor curve. The top curve, what you see in red, is the IE5 thin RM package efficiency. So overall, the result says when you compare the benefits with respect to full load, it is varying from 2%, and when it comes to partial load, we are getting a benefit from 6 to 7%. So now you can imagine at partial loads, if you are giving a benefit of 6 to 7% efficiency, then you can imagine the amount of savings. So there is also a question, you should also come in your mind that none of the motors at site operate at full load. So there is a lot of savings which are expected with respect to this. So continuation of this, as I said, the standard package efficiency is 92.5, and here it is 94.2. There is an increase of 2%. When it comes to the CO2 emission, it is reduced by 2%. So I'm saying that CO2 emission, just to compare with respect to like the CO2 reduction of 110 kilowatt IE5 motor in a year, which may be equivalent to 5 petrol fueled cars off the roads, just to give an example. So talking about one more aspect of cost of ownership. So this is also an important point when it comes to buying a new motor or a replacement of an old motor or a rewind motor. So what is cost of ownership? You can see the picture here. Cost of ownership is nothing but you have a purchase cost, you have a cost of running, and you should also consider the cost of not running. That means you should consider the downtime also. So if the motor fails or motor stops during the operation in the process industry, so definitely you can imagine the amount of loss, production loss, which happens. So that part should also be considered. So this will give you an idea why on the long-term aspects whether to buy a new motor or a replacement motor. So after this, I just wanted to touch upon some of the case studies I've listed here. So this is one example in India. This is Sri Mahabir Ferroalloys. It is a metal manufacturer, steel manufacturer, and in India the part is Rourkela. And ABB had offered IE4 motors of 184 numbers. If you see this side, all the motors were running on DOL or either Star Delta or some other starters. But when the proposal was given for a VFD, it has been replaced. And out of 184, the first phase, we had replaced 68 numbers with VFD. So you can imagine with these motors, the benefit was around 250 megawatt hour savings was given. So further potential with respect to 550 megawatt hour was there. And when we talk about the balance 116, there were total 184. So 116, considering that you have an additional of 550 megawatt hour. So all these applications were related to compressors, pumps, conveyors, gearbox, pellets, and all those applications were there. So all the motors were replaced, and the overall benefit you see, and try to compare the overall savings it is nothing but equivalent to an average annual saving consumption of an Indian village. You can just compare with that. So the next example would be on the Blue Florida Limited. This is a pharma or a chemical company. Again, this was through an OEM, Pratik Engineering. It was selected in India. The place was Visakhapatnam. And 200 kilowatt AC motor along with the AC regenerative drive was given. And because it is a regenerative drive, all the losses are fed back to the system. So you are again saving the energy there also. So overall benefit you see, the annual saving around 66 megawatt hour, which is equivalent to around 4 lakhs savings per machine. And if you see the return on investment, it is only lesser than 3 years. So you can imagine the importance of energy efficient motors. So the next case study on the FDs, this is in Netherlands plant. These are the pumping stations where they supply fresh water to their customers. And this customer is very like give importance to on the sustainability part. So definitely they were very there was a very warm welcome with respect to this customer for asking for the first CNRM motors which were used in this along with the drive. So with this we got around savings around 20% savings, and this was delivered with including ACS 880 was used along with these motors with respect to CNRM motor package. Another example from India is this Orchid paper. This is a recent one where it was 13% saving was used. This is a 55 kilowatt motor, CNRM motor of IE4 efficiency class. And this was also through an integrator, RQ, and then 13% energy savings is given here. This example is JW Marriott. This is a hotel, landmark hotel city in Pune, where the motors were supplied of 15.5 kilowatt of 350 RPM. This is again the permanent magnet motors here, which we had supplied. And overall benefit, if you see, 35% energy cost was reduced, and energy saved in the day is equivalent to charging of an EV car, which can run 4,500 kilometers. So the last one on the pharma industry. This is on the ACG. They make films and foils. Here we are given 5.5 kilowatt for IE5 EC titanium motor, that is on this for the centrifugal applications, or centrifugal pump. And the energy consumption, if you see, it is around 12.59 kilowatt. It was saved over when compared to an IE3 motor. So this ends my presentation. If you have any questions, we can answer now.
Thank you, Lokesh sir, for your very good presentation. Dear participant, Mr. Lokesh is only speaker from South Asia. So thank you very much. Your slide were well structured. I found that. Sir, I want to ask you a question, like regarding the policy point of view. So what are the requirements to be fulfilled to upgrade to the IE3 or IE4 from the minimum standard na IE2 that India is now offering?
Okay. I could not understand it. You're asking from IE2 to IE3, what is the minimum standard?
Yeah. What are the requirements? Policy, maybe technical, what are the requirements so that India can adopt the minimum IE3 standard? Okay.
So from manufacturer point of view, definitely we are having IE2, IE3 and IE4, the complete series, even IE5 also. But when it comes to regulation point of view, in India, the BAS standard, they say minimum should be IE2. So there is no such regulation which has come or which is going to come. Maybe in future, maybe in another 2 years, 3 years, it might come. But at this moment, it is controlled by the BAS body. So unless they give an instruction to all the manufacturers, this is not going to come. So they are going to talk to all the manufacturers, then only they will come up with a proposal.
Okay. Thank you, sir, for your question. And sir, so Wahab, do you have any more question? Lucas, sir, what is the market share of ABB BFD in India? You have any rough idea? So how many manufacturers are over there, or how many importer of other brand ABB?
Okay. Okay. So if you see from the competition point of view, definitely we see Siemens, Crompton, and Bharat Bijli. So these are some three tough competition what we have. And if you talk about the market share, of course, on the bigger frames, the market share is around 40 to 45% in India. For the bigger frames, what I talk about 280 to 450, and smaller frames is around 30 to 35%.
Okay, thank you. So thank you very much, Lokesh sir, for having with us. So uh, now we'll move to another poll session. We'll display a few questions MCQ from yesterday. So hope participant will respond us. Thank you, Lokesh sir. You can be with us during the presentation.
Okay.
Yeah. Do you have any? Participant, you can check your favorite answer.
I'm afraid that Tula, the answer list options are not it's not correct.
You are saying this question not correct or answer?
Yeah, the options are not correct because I sent you the MCQ this morning. Maybe I don't think that's maybe the problem of the. Let me check. Yeah, the options 240, 247, 250, and 255. So maybe the questions listed, the choices list is not correct. I think we can ignore. Okay, this is correct.
Okay.
Yeah, I think we can ignore the question, the question two. This is good. This is good. No problem. Okay.
मेरा बंद कर दे So we can move to next.
Tula, this
Yeah.
is not a good question. I think the question and answer is not correspondingly matched. So we should ignore this question.
This 5 question.
No, it's a wrong question because the function code of rate single hold register is 3, 4, 5. This is I think you mix the the question between yesterday and today. So I think this is a wrong question. We should ignore
So
this
we'll
question.
study it. Okay, go ahead.
It's wrong.
Thank you, Hugo, for your comments.
Yeah, it's okay. So I prepared the MCQ and I did quite well.
Yeah. So okay, so now the MCQ is finished. Okay, we move to the next session. Dear participant, here the engineer Fahad Awan is asking when and where would we get the video recording of this 5 days training, and when we get the certificate. We have uploaded all the presentation till yesterday in our website, which we have shared in the chat box, the link of our website. So for the recording, it will take few days. So then we'll update, so you can find it after 5 days. For the certificate, we also planning to provide maybe coming Tuesday or Wednesday. So now we move to another session, that industrial communication protocol training, that is taken by Mr. Hugo. So I have already introduced him the first day and yesterday. So Mr. Hugo, are you ready?
Yes.
So,
Yeah.
you may.
Okay, can you see my screen? Oh, can you see me?
Yeah.
Okay, so I think I can start. So, good afternoon, everyone. So here I'm again. So as organizer and also I'm the last trainer to finish this, 5 days long time training, technical training or policy training for all of you. So it was my pleasure to make the final hearing of our training. So the title of today's training is also mentioned about Industrial Communication Protocol, the second phase. I can see it's called OPC. So because yesterday I already introduced the Modbus protocol to all of you, and that's for the physical layer. Today I'm going to introduce OPC. I think from my point of view, this is a layer for the cyber world. It's also quite important for all of you. It has a lot of advantages, and I will disclose, something that I learned in last years and also apply to you can benefit from my training or my introduction. And also my profile again as standard steps. And today I'm still the programmer on this. And also I started the OPC industrial communication protocol for IoT for many years. And then I read the document and also I did the practicing of the coding with some typical language like C#, and I will show you later. And so today, I think my introduction will be a little bit shorter than yesterday or even before, but still have a lot of things to introduce with you. and this is our today's introduction. First, I would like to introduce something about the industrial Internet of Things. I think already mentioned yesterday that Modbus is one of the most important protocol for this IoT. But today I want to share you something about the IoT. And also I think IoT, you learned about this or heard about this for many occasions. But I will give some definition. Actually, I steal from some other sources with you. Second, I would like to also introduce or briefly introduce you the IoT communication protocols. And also I would like to highlight the international communication protocol or common understanding of communication protocols importance. And then I would like to introduce the Opc UA introduction, and I will show you why and also how, like before. And also I would like to show you some Opc UA cases. Actually, the smart pump demonstrator, and my smart socket, and also my smart home. It's all based on this Opc UA communication protocol between the server and also client side, and also even the communication between the on-site gateways and also the cloud. And I will also demonstrate something later. Then the title, I use the same graph like yesterday, but I changed the title a little bit. This title today is how machines or systems to talk with each other, or talk to cloud, or talk in the cyber world. And this is a graph I showed several times, and I would like to ask you to pay attention to the right side of this graph, which is the cyber layer. For the physical layer, we use controllers like VFD, like PLC, or maybe other gateway, to take the data from the sensor, and also to take the data from the actuator, and also we can use them as a controller to send the control message, control orders to the actuator to perform like the like Lokesh mentioned, to change the frequency of the VFD, to change the configuration of the PLC, and also maybe change the open rate of the valve, or maybe we can turn the machine on and off. That's for the physical layer I already introduced. And also from my point of view, the Modbus is the most important communication protocol in this layer, and already show you the details or something behind of the Modbus. I hope that you can benefit something from it. But today I'm going to show you when the information comes to cyber world. Cyber world normally mentioned about TCP based on TCP/IP. We have the Wi-Fi connection, we have the mobile network connection, and also we have the internet network connection, and also maybe even like ZigBee or like some other a lot of communication technologies, especially telecommunication application technologies, has been used in this field. It's called cyber layer level. And then we have much more flexibility, and also of course complexity has been added to this system. That's right. But still, like I mentioned, we need a common understanding language to to talk with different systems and different. It's not about device, it's about systems, from maybe one machine to one machine, from one country to another country. And like I mentioned, language is the same thing, because I think you have your own languages. I have my own language. Even in China, we have a lot of dialects, and also I can speak dialect, I can speak Mandarin, and right now I'm speaking English. I think the communication protocol or standardized communication protocol could be the like English in the world, some common understanding language to communicate with each other. We have to define this communication. Of course, a lot of manufacturers or the big companies and also international standardization bodies already invest a lot of efforts in last decades. But still not unified. Still, we are working towards this direction. And but first, I would like to show you something of my understanding of the IoT. Actually, I use Google search to typical, from my point of view, the typical, diagrams, or from internet. From left side, we can see that right now it's mobile phone or mobile apps oriented application. We can use mobile phone communicate with each other. We can use mobile phone to use special apps to control the operation of of the machine. Now of clamps here, we can use mobile phones and message it to the robot, and also we can use mobile phone to communicate with the managers, salesman, or maybe the designer. can also use to, as I think it's for the chip, and also we can use mail to exchange with data. Everything right now, it's a mobile device oriented world. And right now in China, we also use mobile phones to control everything. Take one example is cashless world. In last half a year, I don't spend a cent of cash in China because of the, it maybe it's not relates to the industrial IoT, but still that means in future we can use modern communication technologies and also some well understanding communications to achieve a lot of activities cannot before. And also this is industrial equipment, maybe more industrial oriented. With some centralized systems, we can get orders, we can dispatch the production, and also we can we can let the information flows smoothly among different systems from different layers. So I think this is IoT I mentioned, and I took this sentence from Wikipedia, which is quite precisely describe what I'm going to talk. IoT refers to interconnected sensors. I showed you several times instruments, meters, and also other devices like VFD, like the relay, like other control devices, networked with computers, and also already showed yesterday that we can connect the device by Modbus directly with computers. I think that's previous generation technology, but still it's quite used. If you work in the factory, you can find that in the factories, the computer is connected with a machine, with the PLCs, with the VFDs, and also you send the orders via the cables connected to the computer with some specialized, also particular industrial software to send messages and also send orders via the cable to the to the PLC to control the processing line. But maybe in future you can send the control orders to the PLC and also maybe the VFDs wirelessly. But maybe somebody will doubt that wireless or Wi-Fi connection is not strong enough to or robust enough, reliable enough to control the instant reaction machines. But I think in future the 5G mobile the 5G communication telecom communication technology will change this, because the delay time of 5G is quite small. It has become connected with a lot of devices. Actually, in China, I heard a lot of industrial parks or some factories that deploy the private-owned 5G network within their factory or the industrial park for the internal communication among different devices. And then that means we need some, based on 5G communication protocol, we need some maybe high-level communication protocol like IoT. That means we can also include manufacturing and also management into one system or into different systems. Then, as I mentioned before, the IoT needs common understanding language. But right now, like the real world, even in the IT world, even in the machine world, the communication protocol, there are a lot. Actually, also a mix. Somebody even has no distinction about what's the difference between different technology. I mentioned like the CAN, like Modbus, and also like Opc UA, DA, HDA, and also even I mentioned also Modbus again. A lot of communications. I think it's confusing. I learned and also I studied some maybe literature review. Finally, according to my practicing, that means I programs embedded devices. I want to connect out in the gateway to the cloud, and also I want to to make the maximum flexibility of my cloud application. Finally, I choose that maybe the most important or maybe the most too useful protocol is Modbus here and Opc UA. I already introduced Modbus yesterday, and today I will share you something about Opc UA. So what is Opc UA? So Opc UA actually originates from from 1995. The OPC, it's the abbreviation. The previously the generation OPC is abbreviation OLAY process control. From this name, we can see that it's designed originally to say for the process control for the industries. From 1995, actually, it's initiated not by industrial tycoons. It's initiated by Microsoft, because OLE is one application, or the application interaction technology promoted by Microsoft at that time. From 1995, from its Windows, the first worldwide Windows operating system was published in 1995, the most popular in Windows 1995. Then the design is called, it's the previous, the last generation OPC called OLE process control with abbreviation OPC from 1995. From this big umbrella, they designed three, or maybe even a little bit more, the subset or the specification called OPC DA. DA means data access. That means it can be used to access the data from the server. Okay. Second is called OPC HDA. HDA means historical data access. That means you can take the data, instant data, and also you can take the historical data from the device and for the further analyze and for the further storage. And finally, the last one or the third one called OPC alert and event. Alert and event, that means sometimes the control device, the control system will maybe something important happened or something bad happened in the system. That means it needs the mechanism to report alerts and the event to the higher level control mechanism like computer. Even they can send a message to the engineer or the maintainer cell phone, or maybe even can be automatically call the engineers to remind them that there's something important happened in the system. Please take a look, have a look at the system or take care of the system. And then it's like alert, alarm. I think that's a design for them. And after, I think, 20 or even 15 years development, they realize that maybe, okay, this previous generation of OPC or OLE process control, okay, it's good, but it's good enough because first it restricts to the Windows platform, because OLE is a Windows platform-oriented technology. Then they want to expand this kind of the Windows-oriented product, the technology to multiple operating systems like Linux or maybe the Unix. Second, they have different specified DA, HDA, and those alert and events confused the manufacturers, the third-party service providers a lot. Then after years of negotiation, they invented a new generation of communication protocol called OPC UA. But this time, OPC has different wording. And it keeps the abbreviation, but the full name is totally changed. It's called Open Platform Communication. That means it is not restricted to one platform like Windows. It can be used for Linux, Unix, Mac, Android, and also a lot of embedded devices. That means it's real open platform communication. It can be based on TCP/IP. It can be based on any kinds of the physical layer communication protocol. It just defines abstract communication mechanism between the server and the client. And finally, the UA means unified architecture. From this word, you can see that the unified DA, HDA, and also alert and events into one unified architecture. Of course, they added some special or other features into this kind of mechanism, but still, it's called UA. And also, the OPC means Open Platform Communication Unified Architecture. It's a new generation of Opc Standards family group. The OPC UA, it's supported by a lot of international companies. It originates from like Microsoft, a software company, and also ABB. Several times, actually, and Siemens. Actually, a lot of at least I heard that the high end of ABB and Siemens PLCs, they can support OPC. That means you don't have to, physically connect to the ABB and the Siemens. You just only connect with Ethernet or maybe even Wi-Fi. You use OPC client to connect to the ABB PLC to control them softly. Previously, you have to cable. You need cable to connect to the machine, but maybe I think physically it just if the ABB and also Siemens in a network, TCP/IP network, then you can control and also access this device remotely. Of course, a lot of other international companies support this, like AB, Allen Bradley, the PLC. Let's see the OPC features. These are the OPC features. First, OPC UA is an international standard. Actually, it belongs to the IEC. It's called IEC 62541. That's OPC UA IEC code. It's an IEC international standard. It's not. It's well regulated. I think it's a client-server communication protocol. Like I mentioned yesterday, it's the same with Modbus. Actually, it's the same Modbus. The client means I ask a question, I propose a request to one server, and the server will check out my request and also check my authentication, my access right. If they think it's okay, they can return you some response. Then you can interact or react with each other with such kind of client-server communication model. Actually, the client server is a very popular, or maybe the fundamental communication model of the internet world. Like we use browsers to visit the server, we got the message back, the content, the images, text back. Okay, and this protocol focuses on, or maybe develop some special features for communication with industrial equipment and systems for data connection and control. It's used data connection and control. Actually, from my point of view, it's another called alert an event. It means it can report event happened of the machine automatically, and then it's all like Modbus. I always introduce the open protocol. I would want to introduce something that don't open. That means you have to pay for it. It's open. That means it's freely available and implemented on TPL, the open source license, and also you can get documents for free. Even a lot of the open source implementation of OPC UA has been available on internet. You can search and also you can find. You can do some recoding. You can do customizing of yourself. It's for free. So open. Of course, you have to invest the time to get understanding of it. Second, it's cross-platform. I just mentioned it's not tied to one operating system or programming language. That means it can be used for Windows, Linux, Android, and also a lot of any operating system, maybe even the free RTOS. Those programming language could be C, C++, Java, Python, JavaScript, C#. For any kind of programming language, you can program the OPC applications from the server side and from the client side. It's service-oriented architecture. That means I will show you later, because it defines a set of standard service can be provided by the server. That means the functions of the server. Then you can check, you can propose a request to the server, and the server will provide you corresponding the service. Okay, and then it has infinite complexity. It's very it's a little bit complexity. That's a statistic in September 2020. The specification consists of 3,151 pages in 15 documents. It's a little bit complex. That means if somebody wants to get full understanding of OPC UA, it will take them some time. But I don't think maybe one person can fully control it. Maybe a group will be better choice. But later I will show you, maybe you can get the essential part from this standard by your own, by some, by reading some focus documents. Okay, and then it highlights high security functionality for authentication, authorization, integrity, and confidentiality. That means it highlights the security features, because when the industrial information flows for the cyber world without encryption, without authentication, without the double check of your role, your system, especially the industrial system, will face high risk of hyper, and also maybe some more functions, and also maybe some other, some unwanted things happen. Then it highlights the high security, and also it has some special information model for specific industry. It set a lot of cases, for different industries. It's specified for the oil, gas, buildings, and also the OPC Foundation, the organizer, would like to the industries to develop some subset of the standard model for the specific industries. They also have some official implementation like oil, gas, buildings, and also maybe for the different kind of factory industries. And that's in resources. But first one, I would like to invite you, if possible, to go to the official organization website. This is a union called Opc Foundation. This foundation is responsible for deal everything with protocol. You can just click it. I will show you. Then you can get everything that you want from the official document point of view. Wait for a moment, maybe my internet connection is not very good. It takes some time. From this official website, you can find the free documents, standards, specifications, cases, everything. They are all for free, and also you can subscribe their newsletter. They will send you the latest progress of the UA regularly. Let me check. Yeah, it's a home page. You can find that you can be the member, you can also be the membership. You can also get some. They have a lot of online webinar trainings for Opc Foundation, and also do some certification, and also do some events. You can find a lot. Well, I think I checked the list of the members. Almost all international famous companies, they are the member of Opc Foundation. Here is one China company just joined Opc in recent times. China Science Data Technology Corporation Limited. Then you can check the lowest members. Okay. Then we have a lot of free resources for all platforms and language. Actually, a lot of companies published their open source implementation of the server of the client Opc UA. But I would like to, maybe the most important from my point of view is Opc UA.NET standard, because it's official implementation. Okay, wait for a while. Or from Microsoft by C#. Because I started first read document, then I start to research to start the code of this Opc UA. Interesting. Then from GitHub, you can have every resource that you can have. You can have introduction, you can have overview, you can have features, and also it has samples. It has a lot of interesting information that you want to know. But to be honest, it takes a long time to study. But when you get better understanding of this official document plus this official implementation of the UA, then you will get the door of the industrial Internet of Things world will be open to you. Now you can, if you are interested to see, but we have to open 62541. It's one German implementation, and also you have to add to OPC, and you can have JavaScript and Python, and also series of OPC. You can just open the browser, Google. You can say Opc UA open source. You can find a lot of resources all around the world. No problem. Opc UA open 62541. I think Google it. Okay, no problem. But I would like to highlight the first is the Opc Standards. As I mentioned before, it has 15 documents. That means 15 parts of the Opc UA standards. In total, it has about 3,000 pages. But from my point of view, because I didn't read them all. I read the first 6 parts. That's the core part. And so also maybe 7th line. Actually, the 8th is data access. It's the corresponding to OPC data access and also historical data access. The part line is alarms and conditions. Actually, it reflects alerts and events. And for the rest, it's just maybe some not. It's important to have, but it's not the core part. But the first 6 part will be the most important part. The first one is overview and concept. Even you don't want to get in-depth understanding of OPC, but the part 1 is still worth to read because it's quite short, 30 pages, but to give you overview or concept not only for OPC, but also for the industrial Internet of Things concept. Second is security mode. That's I mentioned. The OPC UA highlights the security of the product, the security of the communication. Then they set the part 2 as the very first part 2 to introduce security model, and then the part 4, part 4 describe the address space mode, like how to organize information, and also services. That means standard service provided by the OPC server. As mentioned, it's a service-oriented architecture. The service described, and also the information model describes how the messages has been structured, and also mapping for different languages. Maybe I think at least if you're interested to read this part, it's quite important. Maybe even you don't do the programming, but it will give you a very good picture of the standard. And this is document you can download from website. And actually, I read that this part 1 to part 6 several times. I think from the part 1 to part 6 in total like 600 to 700 pages. But the core part is about 200 pages. That's enough. But it still takes some time to read and study. And that's my experience because I started to to study or research this protocol for several years ago. I think 3 or 4 years ago. I learned a lot from this kind of standard document reading. Okay, actually for the rest graph, I take from I take the part 1 overview and concept. I took some graphs or figures from the part 1 document. The first is explain why OPC UA target applications. Target applications that from the bottom to up, it's like also a physical layer to cyber layer. For the physical layer, we have PLCs, we have DCS, and also we have industrial networks, and also we have data acquisition, and also a lot of physical layer equipment and devices. They need with some private communication protocol, communication between the physical layer to the OPC UA layer. Of course, I mentioned yesterday, the Modbus plays quite important role here again. And then when you go to OPC control, this control can be accessed by HMI, human machine interface. That means in on-site you can use human machine interface, especially liquid and the buttons to touch and also to control the machine to configure on-site. And also you have the MES. I don't know actually exactly what MES means, but quite important. SCADA. I think that's a core competence from ABB. And then OPC even can be in this layer. And then you can upgrade information to the ERP, like manufacturing, production, maintenance, information system, and also database. Finally, even can go up to the corporate enterprise. That means the high level, even from factories to the management, can get better understanding. OPC UA can be used for different layers for the cyber world. This is cyber world, and this is for the physical layer. And then that's why the OPC target can be, it has very wide range of application in our factories, even in our companies, or maybe in a big group of enterprise. And this is server architecture. Server architecture, it's called its address spaces. It uses one term called load. Load could be like method, object, maybe date value, and also it uses some reference to connect with each other. See, the connect with each other and also with little view it seems like a root, like our file system. We can open the like Windows. We can use this kind of C drive, D drive. If we can access C drive, we can go to the folder list, and then we can go to deep steps. We can got different kind of files. It's the same, but you have to, the server application, the server implementation has to organize and load in different way. Maybe you can collect them together, collect this with this together, or maybe this with this together, different. Then it's real objects, it's reference real object. Then it can be subscribed. You can monitor the loads. If the load changes, the information will be, transferred to the subscriber. You can get the information automatically. That's one important mechanism of Opc UA. I don't think I want to do this in detail, but it's subscription. That means I subscribe to changes of one object, maybe one meter changes. When it reaches maybe some value, it will report the changes to me. Then I can get the latest data. Then I can take some actions to see how I can increase the VFD. We can increase the frequency of the VFD or can decrease the VFD. And also we can take some other applications. This is communication protocol. It's very complex, but I think this graph is quite well. And also this is client architecture. And then we can use you can use client API to send the request via the communication stack, and also we send the request, and also we got response, and also we can get published, and also get notification, and then that way some exchange mechanism between the server and also client. It's like a server client that I already introduced yesterday about even Modbus. I think it follows industrial logic to the communication. It's not that it does not like maybe like chat. We just peer to peer. We are equal. But for the Opc UA, it's not equal. The server and the client are not equal. The client can propose a request, and also the server will check the request and also return a message to control the message that can disclose. Actually, the server can be client can be server. So the role, it can be a chain. Here the client. This is a server plus client. It's a server for this client, and also it's client for this this server. It's from different layers. This is this device semantic layer. That means a lot of servers provide information for the client. So the client takes the information, then it plays a role to send the information to the process layer. Then we, from different layers. But of course, we cannot do the layers by very long chains. But still, the OPC, the server and client can be changed. One program or one application can be client and the server. Like the gateway, like our Opc server cloud, it's a client for the data gateway, but the server for the data saving or the web client I will introduce later. It's the same thing. The same language can be, the same role, a dual role can exist in two, in one entity, and also you can change them. From different levels. This is device level, this is process level. Finally, it can go to enterprise level, even it's internet level or public level. It's possible. And this is the case. Actually, if you listen to my previous training before, that's the same logic I follow. This is a device level, with its Modbus communicate and control the device. Then the device. This is private communication. It can be private. And then I did a standard model in the server. Then we have a client. Client means that this is professional client, and this is a web client, and also we have some other clients. Okay, and I'm going to show you something different. Okay. This is a general client. I just get the address in this address. I know that. I can put in address, and then I can connect to the server. Oh, certificate is trustful. Then I can browse the server like a file browser. This is the server object is the standard server configuration or the operation system, and also their status. I don't want to show you again, and also it shows some server operation status. But I'm focusing pump demonstrators. Actually, right now, we open this folder or this load. We can see that we have two pump demonstrators with ID 10,000, 10,001. If I open this one, if I 10,000, then we have a lot of loads, like file loads. This one, if I click it, you can see it shows the information of this load. The load ID means like a special unified ID, and also it shows this. It's a method. I can call this method to take some actions. Actually, this method means I can activate the timer on the server, and this is the object of the big pump system, because we have 5 pump systems. This is the object of the big pump system. For each pump system, we can get input power, input current, input power, input voltage, and also the PID flow set point. And then we have some other statistic features I don't want to explain in detail. And also here, I can change the VFD operation status. It's a method. I can call this method to change the VFD status. We have input argument, that means parameters, values. Here, we can specify the pump system name, and also we want to set new operation system to be on and off. And also I can set how long it will take effect. Normally be 0, it means I want to turn it on, turn it off immediately. I want to change the frequency on and off immediately. By browsing this, this load, I can, without any further, if this server has been organized the object in correct way, then I can browse and also get understanding of the server like a browser. That because it has description, like they can use some text to describe how the role of this load. Then I can, for the clients, they can browse and also they can check and also they can make some actions. Of course, they can use it to control the device with some other, the client, special client. Okay, this is actually this is a pump demonstrator that we use. Actually, our web application plays a role as client for the pump demonstrator to control it via the server. This is pump demonstrator. And I mentioned modeling is we put 5 VFDs, 5 motors, 5 pumps. We have the two flow meter type 1, flow meter type 2, and also we have 10 pressure meters. In total, we have 19 sensors and actuators, and also smart devices to be controlled and to be connected. And this is a Opc address model. I already show you with my program. Actually, this program is a general browser. It's from the Opc Foundation official implementation. And this is the smart socket. Yesterday I already showed you that this is the sensor or the actuator. This small gateway connect with my home Wi-Fi. It's sending information to the Opc server. Then the Opc server has 2 clients. The first client is called a data saving client. That means it saves the data to the socket database. And then we have a web portal client. This web portal client connects to the server. And then it can control the server and control the gateway and also control the device. And also it uses the data from this database. I'm going to show you. I have a cloud server. I'm connecting with Windows remote desktop. You can see that this is smart socket server. That means it receives the data from the gateway, from the socket. That means it has a power. It has relay is on, means it's on and off. Indicator status means it's receiving the data from the underlying gateway. And it also shows it, but because I turn it on, because for demonstration, this is a server. Actually, this is the data saving client. For each 1 minute, it connects to the server and also to store the data, to take the data, and also store the data to the database. And then I can open the, wait for a while. I can open this web portal. See, I can see the instant value of web portal. And I think it indicate it's connected. I can turn it on and turn it off here. I don't want to demonstrate again. Maybe I'll demonstrate this by, I want to take this one. It will not affect my family's electricity consumption. I can turn it off. Click. No, I think it's offline. Maybe it's offline. Then every time I check it, then the gateway will be connected. See? Okay, right now it's connected. Because normally it has poor internet connection, then it will get offline. I will turn it off. Maybe it's wrong. Okay, no problem. Still, I demonstrate this. Okay, the server and clients have multiple clients, and also here I can get the data analyzed result. I store the data to the server. Then for this is the 24 hours, not 24 hours, the energy consumption of my refrigerator. Okay, that's the same thing. I want to try it again. I don't know why, but I don't know. Maybe. Okay, this is a smart socket. The time is pushing the end. And this is case 3, smart home. I already mentioned, smart home is composed of, from 2 parts. For this part, I introduced the air sensor plus gateway, the power meter. It uses an RS455 Modbus supported gateway to connect to the power meter, and then it sends the information to the cloud. It's Opc server for the air sensor for the power meter, and also it has one data saving client, and also we have this web portal. Okay, I have to log in. Then we have the instant information of the power meter. Oh. Okay, you can see that. Right now, you can see the family consumption is like almost 500 watts, and also the power factor, and also you can see the air quality. I already showed it, and then it has a pet saving client. Maybe I will show you also the server. And this is the data saving client. It takes the data, active power, the PM 2.5, then saves to database. And this is the server. It receives the data from the gateway and also shows it on it. But the advantage of OPC is I don't have to reprogram of the socket. My web portal client can connect to the Opc server here. We don't have to reprogramming of the socket. I just connect to the server. Then I can get the instant information of the socket. Here is a refrigerator. Here is for the TV. Here is for the air conditioner. Here is for the NAS. It's the same thing. You can see that it's the same thing. That means I don't have to reprogram. If we have one standard as Opc server, I don't have to do reprogramming of the server. They'll just connect it. I think that's solve the problem or the question. I think some days one expert proposed that whether how can I connect or get the data from another device, another system. If I know the information of the Opc server, they can better understand it. And also I can connect the database of socket. Then I have the socket statistic in another application here. Actually, this is we connect to the, maybe I can show it in EN, English language, can better understand it. See, and right now I can see that the TV, when it turns on today, my boys turn the TV like 12:30, and then switched off. Okay, this is the advantage of OPC. That means it provides soft interface. Of course, I can also use this client. I will show you maybe like a smart home server. Again, I just connect it. I can browse it. This is an air sensor gateway host. That means it's a host folder for all the air sensor. This is the power meter gateway host. Right now, I virtually has 5, but actually only 1 is available. Then I can get air sensor status. Here's the value. I can get the value. We can see the value. And this is the power. Also, this one is we can see the power status here. I can see the power status of the value. Oh. That means with Opc UA, we can have access with one address. You just need one address. And of course, you have to exchange the certificate. I don't want to explain right now because it's a little complicated. Exchange the certificate, and then use the address, then you can have the access point, then you can use like the open the folders. It can explain the structure of the server. Then you can take the information that you want, and then you can access it by subscription, by rating, by anything that you can to get access of the data of the server. Okay, I think that's all my introduction today. Opc UA, I think it's a very useful industrial communication protocol. It looks a little bit complex for you at the current stage, but I hope that you can. My introduction could just kick off the door or the gate for you. That's all my introduction from my side. Okay.
Thank you,
Hello,
Mr. Wu.
are you finished?
Yeah, thank you very much for your excellent presentation. So I think you did always best. Dear participant, we are coming to the end of this 5 days training session. So I have already informed you that all the presentation we have uploaded except one. So for the recording, it will take few days. Then that will be available on our website.
Conrad actually sent me one question. I think maybe Conrad, just you have to previously last years, we installed the Fluke. Right now with this smart meter, this is the current loop, and also you can also use connected with voltage information with Modbus communication protocol plus with one gateway to the information cloud, and also you have the cloud modeling a little bit. Then you can have the you can have the information on cloud. You can save it to database, and also you can show them instantly in your control panel, virtual control panel, and that's all. Maybe I'm sending you the link of my house, of my home automation. Interesting. House power, instant. Correct. I'm sending you the link. Okay, you can experience. You can check my house energy consumption plus some sockets and also air quality instantly. Okay.
Yeah, yeah.
That means
Thank you, Mr. Rubo. So you have blended your theoretical knowledge with practical. You have displayed so many sensors and this smart system. So I think that will be great for us. Uh, Dear participant, we are coming to the end. So my special thanks goes to the team lead, Mr. Hugo, for presenting your depth, knowledge and experience and making the good team. Thank you everyone for attending. Have the long training session. With your long patience, this event has become successful. So accept my apology for any inconvenience during the conduct of this training session because we had to move from China to USA to Europe. So there may be some problem while switching and interruption. So I believe that you have learned the basic of fundamental of energy saving potential in industrial motor and how they can be realized through the introduction of various measures and hope you will use the learning in your professional life. Now, on behalf of presenters or the resource person, I would like to invite Mr. Conrad to give the closing remarks.
Thank you. Thank you to the SARC Energy Center organizers. I want to give you some final remarks for those people who don't know me, who haven't listened to my introduction. My name is Konrad Brunner. I'm an energy efficiency consultant and I'm based in Switzerland, in Zurich. When I look outdoors, I can see heavy snowing. I don't know what the weather is in your place, but we have snow right now. My final remarks, I'm very pleased with this sort of 5-day intensive training. For the participants, I hope you could enjoy the very wide scope of topics that have been treated. And I think you didn't learn everything, but you learned to know where you want to go more deeply into by yourself. I think you got some kind of an overview, some general items, plus some specific items. I just listening to Hubo explaining you this very interesting monitoring system, which is a very, very smart idea that you can monitor a factory from your home, from when you're on the way. And I hope all the participants can take something home from this wide array of topics and learn where they want to go much deeper. For people who work in factories, I want to say what I feel is very important. Because we talked about oversizing and downsizing, the people in factories have to learn how to measure piece of equipment. And you can measure with very sophisticated gear, or you can measure it with very simple gear. We try to start measuring by simply measuring the electric input. For this, you need a 3-phase watt meter. And when you keep the measuring going for a couple hours, maybe a day, you already have a very fast understanding whether your machine is working in the planned range or whether it's working on a very low load factor. You know, you have learned what it means when a machine runs on a low load factor. It means it has a very bad efficiency. Therefore, for people in factory, make sure you have this sort of watt meter. Earlier, measuring was only done with some kind of current meter, or it was measured only in one phase. We advise that you use a 3-phase watt meter, and with this you can very quickly decide whether a machine that has 10 kilowatt is really running at 10 kilowatt or it's only running at 3 kilowatt or 5 kilowatt. Of course, you can do many more sophisticated measurements when you measure the output, the air stream, the power, the volume, or the water stream. But with the input measurement, you have a very quick overview of whether your machine is performing in the range or in the scope you want. Third point, for the engineers. Engineers, I consider the people who plan factories, who are responsible for the overview of a factory to be renewed, that have an idea that every 5 years you have to go over all machines and check which ones are performing well, which ones have to be repaired, which ones have to be replaced. Or when you have to an expansion of your factory, what new machines you should buy. For the engineers, I would only say go systems. Think about systems. A system is a combination of a motor and an application, a pump, a fan, a compressor, plus when you have a variable frequency drive, plus when you need mechanical gear like transmission and gears in between. A system performance is the goal to achieve by an engineer who is planning a repair, a replacement, or a new installation. If you think only components, you might wind up with doing an improvement. You change the V-belt to a flat belt, okay, you have an improvement of the system. But when you think system, you analyze how the components of a system, the VFD, the motor, the transmission, the gear, and the application, how they perform. Only then you get a very balanced, energy efficient, and well-performing installation machine. Therefore, for the engineers, think system. I want to say something for the business leaders or for the owners of a factory that you're operating. Many of the business leaders, their training is not being an engineer. Their training is being a merchant, a bookkeeper, an economist. And they usually go in a very old-fashioned way that their cost considerations is only buy cheap. And of course, you as energy efficiency conscious people have learned that sometimes the cheapest machine is not the most cost-effective machine. When you buy a new machine, think life cycle costing. Think about that when you buy something which is 10% more expensive, it can save you a lot of money through the next 5 or 10 or 20 years. Therefore, for business leaders, life cycle costing, and not just a quick payback, but the thinking of about 10 years or in bigger machines, 20 years is imperative. And I hope business leaders can understand. Owners of factories, operators of factories have to learn to think in life cycle cost terms. I also want to address the manufacturers and not the big global manufacturers in the US or in Europe, but the manufacturers that sit within the SAARC countries. I know there are many manufacturers of pumps and fans and motors, both in India, in Pakistan, in many of the SAARC countries. And I want to encourage them that these manufacturers should start providing, manufacturing, and delivering higher efficient products. They are usually limited because they also have learned that the guy who orders a machine wants to have the cheapest machine. And the manufacturers have to learn to explain what the high efficient machine means for the guy who buys it and for the guy who operates it. If the manufacturers only sell low efficient machines, i.e. one motors, i.e. one converters, low efficient pumps, low efficient fans, they can never convince a buyer, an operator, to go into higher efficiency and to make from excellent performing components an excellent performing system. Therefore, I want to encourage all manufacturers to go for higher efficient products, and the know-how is there. I know that the know-how is not limited to the US and Europe. There's a lot of know-how in your region. There are a lot of factories that produce these products, and I encourage them to cooperate with other people to do their research and to improve their products for the future market. 6, I want to say something for people from government, people who are in the administration or who are regulators. It was nice to see when Hubo showed the performance of his refrigerator. You know household appliances worldwide have improved over the last 20 years enormously because there was a labeling system and because there was a minimum energy performance standard. The labeling and the minimum energy performance standard was issued nationally. The international standards provide the basis that you can measure correctly the consumption of a machine and that you can compare it and maybe provide efficiency classes, but it's the national legislative body, the national administration, the national government who have to issue the concrete rules for minimum energy requirements. And frankly, in the household arena and with the light bulbs, we made huge progress. I mentioned that. In the industrial area, with the motors and the pumps and the fans and the compressors, and especially in your region, progress is very slow. Progress is not driven by mandatory energy performance standards. Only India in your region has a relatively low motor minimum energy performance standards. To my knowledge, I hope you can correct me, no other country has minimum energy performance standards, neither for motor, neither for variable frequency drive, nor for pumps, for fans, or for compressors. And as I said, if an owner of a factory should not just buy the cheapest component, but the component that is energy efficient over its lifetime, when the country he operates issues minimum requirements, quality standards, efficiency standards, this changes the market situation very quickly, because then every buyer has to buy more efficient products. And be aware that the product that costs 10% more can save you a lot of running costs, operating costs over its lifetime. In many cases, in most cases, I would say, for machines that run more than, say, 2,000 hours a year, an industry machine runs 4,000 or 5,000 or 6,000 hours a year. An industrial machine having high operating hours per year will always profit from a more efficient product being bought at the start. Now, point 7. For all of us, you chose the topic of digitalization. And frankly, this is the new future of technical machines. Before, a machine in industry, even in household, was always considered a standalone. That means you had a machine and you were sitting there and you were switched on, switched off, and that was it. Slowly, electronic controls came into operation. Slowly, with the load control, variable frequency control came into operation. Slowly, remote control that you could see what your machine does, like what Hugo told you. Slowly, a remote control in the sense that you can turn machines on and off remotely, or that you can have optimization programs that compare the efficiency and the operation hours from today with that of last week. Slowly, all kinds of new digital remote sensor-based and digital twin-based machinery comes into operation. I think that's a very big future. I don't think that this will cancel what I said for efficient machinery and efficient systems. To the contrary, when you go to the concept of digitalization, remote control, having a digital twin, you need to have very good machines. You don't want only to be the firefighters and notice when a pump has a failure and you go to change a pump. For that, you don't need very highly sophisticated control and operating software. When you have software of the kind that Hugo just showed you, you can actually control the industrial product machinery of an entire factory, and you can optimize its performance. You can make sure that no hour the machinery is operating with standby, not necessary, or with operating without use. That means you can optimize the machinery, the performance. You will save on operating costs, on maintenance, and of course on energy, and reduce your CO2 emissions. Therefore, for all of us, digitalization is a new field, and as we have learned from the presentations, it's also a complex new field. Traditionally, our factory people are mechanical engineers or electric engineers. Now they need also to be electronic engineers. Finally, I want to thank the SAARC Energy Center for hosting, Tula Ram Pudel for the organization, all the creative speakers, the enduring participants, 5 days, always this topic. I want to thank Hubo for the perfect organization, and I must say I felt honored to be invited to attend. Last thing, you can get help online by downloading the presentations from SAARC Energy Center's site. You can go to the 4EMSA, the Electric Motor System Annex site. It has a very simple name. It's www.motorsystems.org. You can go to CLASP. We have heard a presentation on their standards and label work. You can go to www.clasponline.org. And thirdly, you can go to the site of United for Efficiency, a program from the UNEP, United Nations Environment Program, and this is www.unitedforefficiency.org. Therefore, help is available, knowledge is available, and I wish you success in applying this knowledge for efficient machinery in all your positions you are working. Thank you very much.
Thank you, Kunal Brunner, sir, for your impressive remarks. We are really grateful to have a seasoned personality like you in our event. Your delivery from long-term experience will greatly help to make the South Asian electrical industry more robust and efficient. So thank you very much, sir, for your time with us. Now, I would like to invite Mr. Siddhanti Jha, sir. He's senior engineer from Ministry of Energy, Nepal. Is a participant. He will be sharing his experience with us. Okay, sir. Over to you. Sir, you are. Yeah, sir. Unmute your mic. Just in the GoToWebinar window, you can see the mic. Sir, maybe we'll come to you later. Now, I think I'd like to invite Mr. Hugo. Please, you want to share your experience with our participant with us. Yeah, please.
Okay. So I'd like to, to show my appreciation for the, for the people staying with us for such long time, 5 days. And also, I would like to show my thanks to all the speakers that invest their precious time to show their experience in their field. And also, I would like to say that because we don't know the background, we don't know too much about the background of the participants, we prepared diversified topics, in the digitalization, in the motor system energy efficiency, and also maybe some equipment efficiency. I hope that you can more or less learn from us. And also, I would like to show my appreciation or thanks to Tula, the organizer of the conference, of this meeting. I hope that in future we can work together for in other fields. Of course, we can continue this kind of training in future. And I hope that my knowledge and also my sharing can benefit your daily work. And I think we will see in other occasions anyway. Okay. No more work from my side because I talked too much in the last few days.
Okay, thank you, Mr. Rodriguez. So, Jasa, are you there with your mic? Maybe not working. No, you are not audible, sir. Maybe your mic is not working over there. You are always with us. So, dear participants, now we are coming toward the end, very end of the session. Now, I would like to request Ms. Meena Khurshid Gazeli on behalf of SARC Energy Center to give the concluding remarks. Then our event will be officially ended. Okay, over to you, Ms. Meena.
Thank you, Tulana. Respected trainers, distinguished delegates, participants, ladies and gentlemen, good afternoon. I am Mehnaz Khurshid Gardeli, working as communication specialist at SARC Energy Center. Today, on behalf of Director SARC Energy Center, I wish to convey our special thanks and appreciation to the team leader, Mr. Wu Wu from Top 10 China, and his team in imparting valuable knowledge and sharing their experiences with the participants during this online training of stakeholders on digitizing industrial motor system for energy efficiency. To enhance the expertise of stakeholders from member states in area of digitization of electric motor systems in industrial establishment, SARC Energy Center conducted this 5-day online training sessions that I trust met the best possible purpose of capacity building. I would like to thank the resource persons from different countries who provided valuable knowledge and their experiences in training sessions. I would also like to thank the delegates from member states, participants, representatives from government agencies, academia, energy experts, and practitioners from national and regional organizations for attending this training program. I appreciate the dedication and active engagements of all participants for pertinent questions and sharing their experiences on digitization of electric motor systems. Ladies and gentlemen, we at SCC for the year 2022 have also designed many knowledge sharing programs and hope to continue collaborating with stakeholders. Let me end by assuring that SARC Energy Center will continue to facilitate capacity building activities in area of clean, sustainable and affordable energy for South Asian countries. My sincere appreciation goes to Mr. Turaram Pujal, who is our program coordinator for organizing this important training program. I also would like to thank IT department of the center, who provided technical support and ensured the smooth running of this program. With these words, Ladies and gentlemen, it is an honor for me to declare the online training of stakeholders on digitizing industrial motor system for energy efficiency officially closed. I wish you all a safe and restful weekend. With this, I would like to thank you. Bye-bye.